everyone, this is Kalpana here. In this video, we're going to see a problem from Laplace Transform. So let's get going. Problem: find Laplace Transform of t power n e power t. Okay, so here we are going to use multiplication by powers of t formula. Okay, using multiplication by powers of t. Right, it says that if L of f of t equal to f of s, then L of t power n f of t equal to minus 1 power n into d power n by ds power n into L of f of t. Or we can say this as f of s, or minus 1 power n into d power n by ds power n into L of f of t is nothing but f of s. Okay, let's see. Just compare these two. Let f of t equal to e power at. Okay, let f of t equal to e power at. Now find L of f of t, that is L of e power at. We know that L of e power at is equal to, use the formula, L of v power at equal to 1 by s minus a, right? We all know this formula. Just use this formula here. Now we got L of f of t equal to, the outcome is in s, the outcome is called f of s. L of f of t equal to the outcome f of s, right? Now we are going to find L of t power n into f of t is equal to, if f of t equal to e power minus at, and for n equal to, yeah, you'll have n, right? T power n f of t equal to minus 1 power n into d power n by ds power n into L of f of t. Right, this is equal to minus 1 power n. We don't know what is n here. Just write n into d power n by ds power n into L of e power at. Formula is, yeah, we got the value, right? Write that value. And here we are asked to find the nth derivative of 1 by s minus a. What we are asked to find? Here we need to find d power n by ds power n is nothing but nth derivative. Here d power n by ds power n of this is nothing but nth derivative. We need to find nth derivative of 1 by s minus a. So let's see how we are going to find. You know that d square by ds square is nothing but d by ds into, you can just write this as, right, d by ds. Likewise, d cube by ds cube can be written as d by ds into d by ds into d by ds, right? Or d by ds of d square by ds square, right? You all know this, right? So keep this in one side. Here we'll find the first derivative, second derivative, and third derivative necessary, and finally we'll see the patterns of first derivative, second derivative, and finally we'll write in general which will be the nth derivative. Okay, I'll show you. Fine. Now let's find the first derivative of 1 by s minus a. Right? You can write 1 by s minus a as s minus a inverse, right? Now find the derivative of s minus a power minus 1, which is equal to minus 1 into s minus a power minus 1, right? Into, since we'll just apply this formula, right? Into inner derivative, say Okay, here we'll get inner derivative d by ds of s minus a. This gives us minus 1 into s minus a power minus 1 is minus 2 into derivative of s with respect to s is 1 minus derivative of a with respect to s is 0. So this gives us minus 1 into s minus a power minus 2 into 1, right? 1 minus 0 is 1, since this gives us minus 1 into, we know that x power minus n can be written as 1 by x power n, right? So we can write s minus a power minus 2 as 1 by s minus a whole square. So we'll get minus 1 by s minus a whole square, right? Fine, very good. We know that d square by ds square can be written as d by ds into d by ds, right? Likewise, we'll write d power n by ds power n as into d by ds. Okay, n minus 1, 1. What you'll get? N minus 1 plus 1 becomes n, right? You'll get the same thing. So you'll write d power n by ds power n as d power n minus 1 by ds power n minus 1 into, you'll take one derivative inside. So first we'll begin with the first derivative. Here we'll find the first derivative of s minus a is equal to d power n minus 1 by ds power n minus 1 into derivative of 1 by s minus a is, I'll do directly here. I'm doing the same thing, okay? Instead of using all these steps, I'm doing directly. S minus a whole square into inner derivative of s minus a is 1, right? I'll get minus 1 power n into d power n minus 1 by ds power n minus 1 into minus 1 by s minus a whole square. See, here we got the first derivative. Next, we'll do the second derivative of s minus a, or the derivative of minus 1 by s minus a. Okay, I'll tell you clearly. Okay, just forget about this minus 1 power n. Okay, forget about it. Now observe here. So this is the first derivative value. First derivative of 1 by s minus a is minus 1 by s minus a whole square. Let's now find second derivative of 1 by s minus a, which is d by ds of 1 by s minus a, right? Which gives us d by ds of, we have the value of first derivative of 1 by s minus a, which is minus 1 by s minus a, right? I mean minus 1 by s minus a whole square. Now we'll find the derivative of this, which gives us d by ds of, if you want, I'll just find the derivative of minus 1 by s minus a whole square more clearly. Derivative, okay, equal to, I'll write this as minus s minus a power minus 2 derivative equal to minus, we can write this minus as minus 1 into derivative of, since derivative of x power n is n into x power n minus 1 into inner derivative, say, suppose inner derivative, let it be, because we are going to use this formula here. So derivative of s minus a whole power minus 2 is minus 2 into s minus a power minus 2 minus 1 into its inner derivative d by ds of s minus a, right? Which gives us minus 1 into minus 2 into s minus a power minus 3 into derivative of s minus a with respect to s is 1. Derivative of s is 1 minus derivative of a with respect to s is 0, right? Which gives us minus 1 into minus 2 into s minus a power minus 3 can be written as 1 by s minus a whole cube, since x power minus n can be written as 1 by x power n, right? We all know this, right? So you'll get minus 1 into minus 2 by s minus a whole cube, right? So derivative of minus 1 by s minus a whole square is minus 1 into minus 2 by s minus a whole cube, right? Here we have the first derivative, we have minus 1 by s minus a whole square, right? First derivative we have minus 1 by s minus a whole square, and in the second derivative of minus 1 by s minus a we have minus 1 into minus 2 by s minus a whole cube. Let's see what we are going to get for the third derivative of 1 by s minus a, right? I can write this as d by ds of d square by ds square of 1 by s square, 1 by s minus a, right? I have the value of d square by ds square of 1 by s minus a, which is minus 1 into minus 2 by s minus a whole cube. Clear? Now let's find the derivative of this part. Let's see what we are going to get. Just need to observe, okay? Don't be in a hurry. This is not a video for people who are in hurry. If you want to learn, please observe. Now I am going to find the derivative of minus 1 into minus 2 by s minus a whole cube. Okay, I'll write this as, here minus 1 and minus 2 are constants. I'll write this as minus 1 into minus 2 into 1 by s minus a whole cube derivative. I'll just find the derivative of 1 by s minus a whole cube, because minus 1 and minus 2 are constants. I'm taking it outside the derivative. Okay, simple. Equal to minus 1 into minus 2 into, you can write this as s minus a power minus 3. Now find its derivative. This is equal to minus 1 into minus 2 into, derivative of s minus a power minus 3 is n into x power n minus 1 into its inner derivative, that is d by ds of s minus a, right? Which gives us minus 1 into minus 2 into minus 3 into s minus a raised to the power minus 3 minus 1 is minus 4 into derivative of s with respect to s is 1 minus derivative of a with respect to s is 0. 1 minus 0 gives 1, and we can write s minus a power minus 4 as 1 by s minus a power 4. So this gives us minus 1 into minus 2 into minus 3 into, you can write this as 1 by s minus a power 4 into this 1, which gives us minus 1 into minus 2 into minus 3 into 1 is minus 1 into minus 2 into minus 3 by s minus a power 4, right? So the answer to this is minus 1 into minus 2 into minus 3 by s minus a power 4. Clear? Fine. This is enough. See, here we find the derivative of 1 by s minus a. The derivative of, first derivative of 1 by s minus a is this, second derivative of 1 by 1 minus a is this, and third derivative of 1 by s minus a is this, right? Sorry, 1 by s minus a, right? Yeah, I'm telling right. So now I'll write all this in one place, and I'll show you how you're going to get the nth derivative of 1 by s minus a using this 3. Okay, let's see that. Yes. So we have first derivative value, second derivative value, third derivative value. Derivative of what? 1 by s minus a. Okay, you have to be very clear. We are finding the derivative of 1 by s minus a. Okay, the first derivative of 1 by s minus a is this. Second derivative, the value of second derivative of 1 by s minus a is this. The derivative of third derivative of 1 by s minus a is this, right? Let's write for nth derivative. Now we have to use our brain. Okay, nth derivative of 1 by s minus a equal to, see, in the first derivative you have minus 1, the second derivative you have minus 1 into minus 2, the third derivative you have minus 1 into minus 2 into minus 3. What shows this? In the nth derivative we may have minus 1 into minus 2 into minus 3 into so on into minus n, right? Am I right? Think. So I think you got something here. Right, I'll tell you. So here we can write this as minus 1, okay, by s minus a whole square, and here you can write minus 1, and you can write this minus 1 as minus 1 into 2 by s minus a whole cube, right? And minus 1 into minus 1 can be written as minus 1 whole square into this 2 by s minus a whole cube, right? And here we'll write this minus 1 as minus 1, and here we'll separate minus 1 from this minus 2. We can write this as minus 1 into 2. Here we'll write minus 3 as minus 1 into 3 by s minus a power 4. From this we'll get minus 1 into minus 1 into minus 1. We have 3 minus 1, right? So we can write this as minus 1 whole cube into 2 into 3 by s minus a power 4, right? Is this enough? No. We can just break down one more thing. Here you can write minus 1, just minus 1 as minus 1 into 1. Here you can write minus 1 whole square into 2. This 2 can be written as 1 into 2. Okay, observe. Right. Here we have 3, right? I mean 2 into 3. We can write this 2 into 3 as 1 into 2 into 3, right? And in the first derivative we can write minus 1 as, see, if you notice here you're having minus 1 cube, minus 1 square, and here you can write this minus 1 as minus 1 power 1. Now can we write the nth derivative of 1 by s minus a using these 3? Observe. Yes, you can write. See, for the first derivative you have minus 1 power 1 into 1 by s minus a square. We have 1 in the denominator, you got square. Okay, if you have 2 in the denominator, you got cube. If you have 3, you got power 4 in the denominator. Right, clear? Right. And if it's 2, you got minus 1 whole square. If it's 3, you got minus 1 power cube. Good. So I'm going to write this now. Nth derivative can be s minus a. If it's 3, you got 3 plus 1, 4. If it's 2, you got 2 plus 1, 3. So if it's n, you'll have n plus 1 to the power of s minus a. Right? Fine. And here in the numerator you'll get, if it's 3, you'll get minus 1 cube. If it's 2, you'll get minus 1 square. If it's 1 power 1, you'll get minus 1 power 1. So if it's n, you'll have minus 1 power n. Good. Right. Now, next part. Here you have 1 into 2, 1 into 2 into 3. If it's power 1, the first derivative, you have 1. In the second derivative, you have 1 into 2. The third derivative, you have 1 into 2 into 3. What about the nth derivative? In nth derivative, you'll get 1 into 2 into 3 into so on into n minus 1 into n. Okay, I'll write it again. You'll get minus 1 power n into 1 into 2 into 3 into so on n minus 1 into n by s minus a power n plus 1. Right? Since we know that n factorial is nothing but n into n minus 1 into so on 3 into 2 into 1, or 1 into 2 into 3 into so on, or n factorial equal to 1 into 2 into 3 into so on n minus 1 into n, right? So you can just replace 1 into 2 into 3 into so on into n as n factorial. Then this becomes minus 1 power n into n factorial by s minus a power n plus 1. So this is the value of nth derivative of 1 by s minus a. Simply. Okay, fine. Now observe, now coming to the problem, you can just write minus 1 power n into this term directly here. Okay, but I'll show you here. We'll write this, and now I'll take one derivative inside the bracket. Okay, how we can take one derivative? If you take one derivative inside the bracket, here you'll get one derivative less than this, right? So one derivative less than this will be one derivative less than this, minus 1, which becomes d power n minus 2 by ds power 1 by ds power n minus 2, right? So you'll get d power n minus 2 by ds power n minus 2 into d by ds of minus 1 by s minus a whole square, right? So the value of second derivative is this one. You'll get the same thing. If you want, you can do it here itself. Minus 1 power n into d power n minus 2 by ds power n minus 2 into derivative minus 1 into derivative of 1 by s minus a whole square is minus 2 into s minus a cube. Simple, right? He'll get the same thing. He'll get this. Okay. So finally, let's break it down for our convenience. We'll write this as minus 1 into, you'll write minus 2 as minus 1 into 2 by s minus a whole cube, which gives us I'm writing the same thing here, okay? Minus 1 power n into d power n minus 2 by ds power n minus 2 into minus 1 into minus 1 can be written as minus 1 whole square. That is what we have written here, right? Into this 2, I'll write this 2 as 1 into 2 by s minus a whole cube. Okay, finally, okay, you just need to observe, right? We have done all the observation here, right? We know that the final derivative, you can't just find these many derivatives, right? We'll just simply write down the nth derivative directly. We have left this minus 1 power n while doing the process, so just write this minus 1 power n, which is a constant or some number or something. Okay, apart from the derivative, you have minus 1 power n. Just write this down. And the nth derivative, you need to write the nth derivative just by observing the terms under this bracket. We'll write the nth derivative. Already we have done, right? Just write it down. Minus 1 power n into n factorial by s minus a power n plus 1. Good. So here you have minus 1 power n into minus 1 power n. You'll get minus 1 power n plus 1, which is minus 1 power 2n. So you'll get minus 1 power 2n into n factorial by s minus a power n plus 1. So how that? You need to know the value of minus 1 power 2n. So what is the value of minus 1 power 2n? Let's see. Minus 1 power 2n. We know that a power m whole power n equal to a power m into n, or we can write the same thing as a power m into n equal to a power m whole power n, right? Fine. Now we can write minus 1 power 2n as minus 1 whole square raised to the power n, right? A power m whole power n equal to minus 1 whole square is 1 power n. 1 power n is again 1. So the value of minus 1 power 2n is 1. So this becomes 1 into n factorial by s minus a power n plus 1, right? Which gives us n factorial by s minus a power n plus 1, right? Therefore, L of t power n e power at equal to n factorial by s minus a power n plus 1, which is a required solution to the problem. Okay, so don't be in a hurry. You all need some patience to understand this problem. Okay, fine, and this is how we'll solve. So first of all, understand the problem. What we are asked to find is Laplace transform of t power n into e power at. Okay, t power n into e power at, we'll just use multiplication by powers of t formula. Okay, so here we need to find the nth derivative. Nth derivative of L of f of t, that is nth derivative of e power at. Simply, you'll find the nth derivative of e power at. So this is how we find the nth derivative of e power at. First we find the first derivative of L of e power at, that is 1 by s minus a, and next you'll find the second derivative of 1 by s minus a, and next you'll find the third derivative of 1 by s minus a. Using these three, okay, we'll find the nth derivative in general. We'll just observe these three and we'll write the nth derivative, and this is what you get in nth derivative. Just you'll substitute in the nth derivative. Okay, this d power n minus 1 by ds power n minus 2. Okay, here we got the second derivative of 1 by s minus a, I think. Yeah, so directly it's not possible to find all the n derivatives. Okay, don't expect me to solve all the n derivatives. It is not possible because you get so many numbers. Okay, fine. So finally you'll write minus 1 power n. This is the number or something which is apart from the derivative of 1 by s minus a. You'll just write 1 by s minus 1 power n into the nth derivative of 1 by s minus a, value of nth derivative of 1 by s minus a, and you'll just simplify it. Okay, don't be confused, it's just easy problem. All you need to do is just observe. Okay, if you observe once, you can just do the same thing, the same problem anywhere, anytime. Well, we have seen a problem from Laplace transform in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.